On March 4th, 2022, there will be a collision between a spent rocket booster and our moon. This is the first long-circulating piece of human-made debris to smash into the lunar surface. On March 4th, humanity will see an old rocket booster smash into the far side of the moon. It will be the first time that a piece of human-made space debris has hit a celestial body other than Earth without being aimed there. The booster is assumed to be part of a rocket that launched a small spacecraft towards the moon in 2014, although that spacecraft returned to Earth successfully. The booster is thought to have been zipping around chaotically in space ever since that time. It has been mentioned that lunar gravity is now drawing the piece of space debris very close to the moon, and it will soon pull it into a fatal collision with the far side of the celestial body. The smash is expected to produce a puff of debris and will leave behind a small crater on the lunar surface. This incident poses no immediate danger to humans or any other spacecraft, but with at least half a dozen craft scheduled to reach the moon in 2022, concern is growing around the lunar surface becoming an unintentional dumping ground. The opinion is that this piece of space debris has been careening around space for more than 7 years and will collide with the moon. Many persons have stated that the problem with space debris is that more than 12,000 Earth-orbiting satellites have been launched since the space age started in 1957, and about 5,100 of those are still operational. Altogether, the agency estimates that there are more than 36,000 pieces of space debris bigger than 10 centimeters across, whizzing around in Earth's orbit. These include dead satellites, as well as the remnants of past launches and anti-satellite tool-related tests. It has been stated that around the moon the space is less crowded, but scientists are concerned that it might not stay that way in the future. A research team, along with a planetary scientist, has utilized telescopes to regularly track the positions of more than 150 objects in the space around the moon. So far, their findings have concluded that at least 90% of the objects are debris. The team has been tracking the object that's on course to hit the moon. They have analyzed how sunlight reflects off it to confirm that it is made of a similar material to the rocket booster that was launched in 2014. The object had initially been identified as a part of the X-rocket booster, but analysis showed that its properties did not match that craft. Astronomers will not be able to watch the impact from Earth as it happens, because the collision will take place on the far side of the moon, probably in or near a crater named Earth-sprung. But several moon-orbiting spacecraft will try to spot it or its aftermath. The rocket that is going to hit the moon will serve as an accidental experiment and will provide information on the physics of impacts in space. On March 4th, 2022, a spent rocket booster will hit the surface of the moon at nearly 6,000 miles per hour. Once that has subsided, NASA's Lunar Reconnaissance Orbiter will move into position to get an up-close view of the crater and hopefully provide some information on the mysterious physics of planetary impacts. Scientists believe that this unplanned impact will serve as an exciting opportunity for research. The moon has been a steadfast witness to solar system history, its heavily cratered surface recording innumerable collisions over the last 4 billion years. However, researchers and scientists rarely get a glimpse of the projectiles, usually asteroids or comets, which form these craters. Without having knowledge of the specifics of what created a crater, there is only so much that researchers and scientists can learn by studying a crater. The impending rocket impact will provide an opportunity for scientists and researchers to view an experiment that could reveal an abundance of information about how natural collisions hit and scour planetary surfaces. A deeper understanding of impact physics will go a long way in assisting researchers to interpret the barren landscape of the moon and also the effects impacts have on Earth and other planets. Astronomers are aware that the object is an upper stage booster discarded from a high-altitude satellite launch. It is approximately 40 feet or 12 meters long and weighs approximately 10,000 pounds or 4,500 kilograms. Evidence suggests that it was likely from a rocket launch in 2015 or one in 2014, but both parties have so far denied ownership of the rocket booster. The rocket is scheduled to hit the vast barren plain within the giant Earth-sprung crater just over the horizon on the far side of the moon from Earth. A few minutes after the rocket touches the lunar surface, there will be a shock wave which will travel up the length of the projectile at several miles per second. Within milliseconds, the back end of the rocket hull will be obliterated with bits of metal exploding in all directions. There will be a second shock wave which will travel downward into the powdery top layer of the moon's surface, called the regolith. The compression of the impact will eat up the dust and rocks and generate a white hot flash. This could be visible from space if there happened to be a craft within the area at the same time. Scientists have said that a cloud of vaporized rock and metal will expand from the impact point as dust and sand-sized particles will be thrown skyward. Over the course of several minutes, the ejected material will rain back down on the surface of the moon. Around the crater, virtually nothing will remain of the rocket. So far, it is expected that NASA will observe this experiment. Through the observation of this accidental experiment with the Lunar Reconnaissance Orbiter, planetary scientists will have an opportunity to observe a very similar crater in daylight. It will be like seeing the El Cross crater in full detail for the first time. Since the impact is going to occur on the far side of the moon, it will be out of view for Earth-based telescopes. But about 2 weeks after the impact, NASA's LRO will begin to get glimpses of the crater as it orbits above the impact zone. Once conditions are clear, the lunar orbiter's camera will start taking photos of the impact site with a resolution of about 3 feet per pixel. Like, comment, share, and subscribe. Thanks for watching. Goodbye.